Hey pre-calcers, just want to take a little bit of time out of your day to take a look at the Quizizz problems dealing with P6. There were only 6 problems here, but it seems as if we were having a little bit of difficulty with it, so I just want to make sure we understand what's going on for all of these. While I work through this, I might sketch out diamond method on the side, so recall that whenever we factor trinomials like this, diamond method helps us to keep our information organized before we make a move. So we know that the product we're aiming for, in this case, number-wise, is -6. Our sum is 5. So we're thinking about factors of -6 that add up to +5. And one of them has to be negative, because the product's negative. The only way this is going to work is if we have -1 and 6. For this, and we'll use this information in a second. With 5a plus 20, 5 is common with 5 and 20, so we take that out. We also see a squared minus 1, which is a difference of squares. And 5 is just 5. So what we're going to do here is just rewrite everything we can in its new factored form. So with the first fraction, this will be 5a plus 4 over 5. I know I'm dividing, but now I'm going to multiply and switch around so that this factored form is now in the numerator with a plus 6, a minus 1. Then finally, the difference of squares, a plus 1, a minus 1. So what happened? We factored everything. We flipped the fraction. And we multiplied. Now we're going to cancel. This may help you if you're a fan of step-by-step processes. Of course, factoring, you saw this in P5. So if you need a refresher on that, please go back, look through your notes, look through that video. It's on Classroom if you need it, or ask me a question if you're still stuck. But at this point, we're going to cancel whatever we can. So I know a minus 1 can be canceled. 5s can be canceled, and that's it, leaving us with a plus 4 up top and a plus 6 all over a plus 1. That's it. I think that one's pretty simple. For the next problem, this has a little bit more now with the factors, but I know that we're multiplying, so that's a little bit easier. With the first fraction, 35 and 25 don't have a variable in common. But what number do they have in common? They both end in 5, so take out 5. Which you can then write as 7n. 5 times -5 gets us -25, so that's good. We see some similarities here. 63 and 45 are both divisible by 9. So we'll take that out. 9 times 7 gets us 63. N is along for the ride. 9 times -5 gets us -45. Then a little bit more of that over here with 9 getting pulled out, n plus 1 being left. N plus 6. N plus 1, easy factoring. All right, now what can we cancel? This is the third step. We'll use red for this. I know we can cancel 9. We can cancel 7n minus 5. N plus 1, or sorry, 7n, yeah, 7n minus 5, n plus 1, leaving us with 5 over n plus 6. Here you go. A little bit more heated up here with problem 3. I'm going to focus first on the first fraction. I know that these are both divisible by 2, and they both have v involved. The lowest exponent they share is v squared, so we'll take that out. 2v squared times 10 will get us back to that 20v squared. We can then deduct v. Down here, 4 is visible. Factor that out, get you here. Next fraction, 8. So then 8 times v gets us 8v. 8 times 5 gets us 40. Down here, 6v squared can be taken out. We can leave v and plus 5. We're good. So what can cancel? Easy to spot the v plus 5. What's tricky about this one is that although these look very similar, the 10 minus v and the v minus 10, we are allowed to cancel these, but the way we need to go about it's a little tricky. And the one example I've been giving is that when you work with fractions, like let's say you had 5 dividing with negative 5, you know this outcome's negative 1 because they look very similar, but one's just negative. So we're actually allowed to do that same thing here. So we can cancel this, but this is pretty much now saying that 2v squared over 4 is multiplying with negative 1. And then multiplying with everything that's over here, just to clean it up a little bit. So what can we do now? We can also cancel v squared here and here. 2 over 4, you can rewrite that as now negative 1/2. Multiplying with the simplified version of this fraction, which is 4/3. So this gets you negative 4 over 6, which is negative 2/3 when simplified. So a lot of fancy fraction work here. Don't get discouraged about this part. You just got to see more of it and then you'll get it. Down here, we factor this out. I'm not going to sketch out diamond for, I will. I got time. Product here is negative 18. Sum is 3. Factors here are 6 and negative 3. So this will be x plus 6, x minus 3. We can factor 3 out of x plus 18, so now it's 3 parentheses x plus 6. And this is multiplying with the factored form of x squared plus x minus 90. So we could do positive 10 and negative 9. That works. Oh, now it's going up here. My bad. But that's actually okay, because then this becomes x plus 10, x minus 3. So the diamond for this would look like the 30 and then 7, but negative 30, so positive 10, negative 3. Done. All right, cancel away. X plus 10 is gone. X plus 6 is gone. X minus 3 is gone. X minus 9 over 3 is left. We're done. Next one, 10's common. Get rid of that up top. Get rid of it again down here. Oh, no, only need 7. Multiplying now with m plus 7, m plus 1. Again, basic factoring. You need to know how to do it. What can we cancel? Definitely the 10s. Definitely m plus 7, m plus 1s, m minus 2 is the only thing left over. Done. Last problem. What's cool about this one is that if you're really strategic, you can notice that n squared plus 10n plus 9 is multiplying with 8. And in the denominator here, we also have a duplicate n squared plus 10n plus 9. So what's cool is that since they're the same size, same trinomial, same degree, same signs, we're allowed to just cancel both of them right off the bat. Unless you want to factor them, in which case go right ahead, but they're just going to cancel. This eventually leaves you 8 up top, 80 in the bottom. 80 is divisible with 8 and 10. 10s can cancel. 1/10 is your answer here. These problems are tough. You definitely need to know your factoring, but don't let any little difficulty discourage you. Just be consistent. Look back at factoring if you need to, and let me know if you have any questions. Thanks for watching.